Okay, cool. Thanks for joining. Hopefully you have a strong interest in Python, as this presentation is definitely going to mostly be about Python. Um, Joe has kindly volunteered to present his kola API, which is, so you probably know Joe actually, he created a VS Code plugin for Q. He's created a number of other open source components that are really good work. And when I saw kola and began to use it, I was really impressed. So hopefully you find it of interest. Uh, Joe, it's over to you.
Thank you, Ryan. Um, so yeah, so my name is Joe Shinonome. Today I'm going to introduce you the Kola, the fastest Python interface to KDB. So here's a bit about myself. I think some of you may know me as the creator of VS Code plugin for KDB. I also writing some interfaces for other programming languages to KDB. Like JKDB, a high performance modern JavaScript interface to KDB. And also a Geek, that's a Golang interface to KDB. And last one is this Kola. It's actually a Python, Rust, and potentially R Polars interface to KDB. So I think that there's a few packages you can use to interface with KDB so far. Like there's QPython, and it uses a bit of Python. There's PyQ, written in C, and there's PyKex, the official Python package to KDB. And last one is Kola. So I'll just go through one by one. QPython is actually only use really small amounts of Python code base, and that's only for uncompressing IPC messages. The deserialization is actually in Python, and this part is pretty low performance. Because of this, Kola is actually 10 to 20 times faster than QPython. And there's a PyQ, which is written in C. It allows you to run Python code in KDB and also run Q code in Python. But for the most cases, Q objects cannot be used directly by Python packages. You still need to convert it somehow into pandas, numpys before you try to apply machine learning packages. So there's another reason. Such projects are actually too complicated to maintain. Python code in Q cannot be linted and formatted. And the Q code in Python is really not necessary. If you want to do Q development, just use Q Studio or just VS Code plugin. And PyKex, the official one, they use Python, 9% of source code, C code, and Q code. So the PyKex actually wrap KDB processes in Python and store Q objects in Q processes. So it actually provides data frame interface to Q table, the table on the Q process. So again, you need to convert it, the Q table, to pandas of PyArrow for some Python machine learning package. And this conversion is actually low performance and requires Python developers to learn some Q knowledge to use to take a full use of the features. And of course, you need to pay the license. The setup for Windows, especially, you have to install several dependencies before you can install this PyKex. And startup questions just are quite annoying. Keep asking for license file. Python code base is difficult to maintain. There's no proper ID for Python. And I think it's going to take some time for PyKex to support NumPy 2.0 because this part is actually in Python, and this is actually a big upgrade. So I wrote Kola in Rust. Most of the code is actually Rust code. So core part on compression, deserialization are in Rust. It's actually C-level performance. It does better in memory management 30 or 50 less memory when query data from KDB, and better deserialization performance using parallel computing. It supports latest Python without changing code and much bigger Polars community to support data frame interface. So most machine learning packages are going to support Polars directly. Better performance of converting data to NumPy or pandas. It's already support NumPy 2.0. And for Python developers, you don't need to know KDB knowledges. And I didn't specifically define anything that's for KDB in this Python package, if you look at it. So there's a comparison between PyKX, pandas, and polars. So here's a comparison of PyKX, pandas, and polars. They all provide a data frame for Python. PyKX uses KDB table as backend. Pandas use NumPy or PyArrow as backend. Polars use PyArrow as backend. Polars is between 10 or 100 times as fast as pandas for data frame operations. And Polars has the same level of performance as, or even faster than KDB. Polars can be used for almost all PyKX, actually KDB table operations. So inequity join for Polars is in progress. This is a correspondent to PyKX window join. Pandas is still the most supported data frame for Python machine learning packages, but Python machine learning packages support for Polars is a work in progress. There's a huge community that's pushing this way. So here's some profiling when query data using kola or PyKX. You can see when you query data call think function using kola, there's only 900 functions calls. And that's a big number is actually instance a Python function. On the other hand, if you're using PyKX to call think function, it's actually 200 times more functions calls, and a lot of calls happens in this selector.py code base. I think from these two profiling screenshots, you can see kola is a more efficient in some sense. So this table shows the query performance comparison. When to compare with PyKX, we have to combine kola and polars because PyKX provides interface and also data frame. So when you can see all these red lines are mostly provided by polars, and blue and red line are provided by kola. So for the large number in speech columns, actually kola plus polars is faster. There's only two laws actually slow is sending polars to KDB compared to sending KDB format to KDB. So when you convert the polars data frame to KDB table, you have to do some check for nulls and convert the nulls to like a minimum integers in that case. So it's a bit slow when you send polars data frame to KDB. But think of it this way: if you send a non-KDB to KDB, kola plus polars is much faster. Because if you look at send the pandas data frame to KDB, it's actually 5 times when it's small table. Even it gets a bit bigger, it's still like 1 time faster than PyKX. So the keyword is parallel computing. I'm going to show you a bit about this deserialization happening in kola. So this IPC messages has a table and there's several columns in bytes. And usual way is deserialize column 1, deserialize column 2, deserialize column 3, and then merge it into table. But on kola side, it's actually do some pre-calculation, try to get the first start position and end position for column. So on the column side, you actually try to get the start position and position for each column, and then deserialize all columns at the same time, and then merge into table. So that's why it makes column faster than Picase when interface with KDB. So I'm going to do a small demonstration about when create data using kola and Picase. So let's see this one and this one. So I have defined a table that has 20 million rows and 64 columns, and I'm going to try to query with it using Picase. So I'm running this, and now I'm going to time it. You can take a look at the CPU and memory usage. Probably focus on CPU first. You can see the CPU will never exceed 100%. So you can see here, right? It's only at most 100%. So it will never exceed one core when core data. So deserialization is happening using one thread. And memory still changing. It's taking something. So this one just persist this table. Persist the table in Python memory. Now let's check how memory is used is 2.3 gigabytes. So that's Picase. Let's take a look at the other one, kola. So I'm going you need to take a look. I think at the second or the third line. I'm going to run this now. Run this. So here you can see, right? The CPU is actually 300 something, and it takes less than like 700 milliseconds for this. And then I'm going to persist this into Python memory. Now let's take a look how much memory is actually using 1.4 gigabytes. So compared to Picase, it's only use 30 or 40 percent less memory here. So I added some features since version 1. So there's some millennium guys asked me to support a bigger IPC message, so I changed it to support protocol version 6 IPC message. So now you can send up to 1 terabyte IPC message. Also, there's some other features added as CD asks, like timeout, retries, and function to generate KDB IPC message, just like -18 internal functions. Now it also can subscribe to KDB feed handler. So why kola? First of all, it's open source and free for latest Linux and Mac OS and Windows. And it is the most efficient and fastest way to create data from KDB and send non-KDB data to KDB. Extremely fast data frame operations powered by kola. And it's very likely supports Python 3.13 in this October, right after it is released. And it also can be extended to support R. It already works. I just never made a proper release. And that's all. And thank you for all the attentions. And you can try kola today. Just use pip install kola. Let me know if you have any questions.
So Joe, basically it's like 10 times faster than the others, partly because it uses polars. Is that the basic one for my takeaway, I guess?
That's so the 10 times or 20 times faster than Python. That one is provided by kola. It's not polars. Yeah.
And you programmed all of this in Rust?
Yes, all of them in Rust. You all can take a look at the source code.
Cool. Does anyone have any questions? Feel free to type them in the chat or shout out. That might get messy.
So I think there's the guys ask about compatible with a Python 3.8. Yes, it is compatible with 3.8. But if you're using a really earlier version of Linux, then it could have some issues. So Python supports streaming. I guess when you say streaming, do you mean like subscribe to a feed handler, just keep getting the data all the time? If that's the question, Kola also supports that now. Yeah, yeah, yeah.
Cool. Great work, Joe. Cool to see something so fast. If anyone else has questions, Joe and both myself will stay to the end. Okay. Thanks, Joe. Thanks for
Thank
mentioning
you.